Okay, let's give you guys some practice now. So find the domain for this multivariable function. So press pause and have a go. Okay, so to do this, to find the domain for a multivariable function, try to look at the function and figure out when it will break down. Well, this function will break down when this thing here equals 0. So make this demand where this thing here cannot be equal to 0. Let's just add both sides. Let's just add this to both sides. So that will then give us this. Cannot be e to the power of xy. Let me just switch the two around. Cannot be 17. Well, what does this mean? Well, let's take the natural log of both sides. So that will then give us this. Cannot be the natural log of 17. What does this mean? Well, divide both sides by x. That will then give us this. Cannot be. So when you look at this, in your mind, picture this graph. Natural log 17 over x. So this is very similar to y equals 1 over x, but you times a constant because this is a constant. So it's like me asking you to sketch this graph. 7 over x. So you would sketch 1 over x, which will look like this, and then with a constant in front of it, it just squeezes it. So it will look very similar to 1 over x. The point I'm trying to make here is that when you look at this, in your mind, picture. Well, when you sketch it, hang on, bear with me. When you look at this, in your mind, picture the xy graph, and then draw this thing here. So draw y equals natural log 17 over x, which will look something like this. So when you look at this, it just means that the domain can be anything on the 2D plane except from when it lies on top of this line and on top of this line. So it can be anything, but just make sure that it doesn't lie on this line and this line. So your domain can be written as this. xy on the 2D plane such that y cannot be this thing here. So when you look at this thing here, in your mind, picture the xy plane very similar to 1 over x, which will look something like this. The domain can be anything on here except from this line and this line. So when you look at this function, your x axis will be here. It matches up with this red thing here, your x-axis, and your y-axis will be this thing here. So imagine you're looking down on this thing here. You're looking down on top of it. 1 over x, very similar to 1 over x. You see, everything's fine except from this, except from anything that lies on top of this line. You see, on top of this line, you can see that it breaks down because you got to imagine you looking down on top of this along the thing that's very similar to 1 over x. You can see it breaks down. You can see that it breaks down somewhere along here. Well, I hope you can see that. So hang on. So I hope you can see that along here it breaks down. Along here it breaks down. So you see. So this is your y, your x. So you can see that along here it breaks down. Well, I hope you can see that. So next question. Find the domain for this function. So press pause and have a go. Okay, so to do this, when will this thing break down? This thing will break down when this thing is precisely equal to 0. So so make this demand. The whole thing here, the denominator. Hang on, let me think. The denominator cannot be 0. What does this mean? Well, let's exponentiate both sides with base e. So that will then be this 10x plus 10y cannot be e to the power 0. So basically I'm saying, well, at the moment this is one block and this is another block. I'm saying exponentiate both sides with base e. That's what I'm saying here. So these two in a way cancel each other out, leaving you with this thing here. And then e to the power 0 is actually 1. So what I'm saying is that the domain for this function is such that this thing here can never be equal to 1. So what does that mean? Let's try and rearrange it to make y the subject. So let's take away 10x from both sides. So so that would be 10y cannot be 1 minus 10x. Let's divide both sides by 10. So that would then be this divided by 10, and then this would then be minus x minus x. So in your mind, picture this. In your mind, your domain would be something like this. Your xy plane, and then this is a straight line, negative gradient of 1, intercept of 1 over 10, something like this. So make sure y cannot be anything on this line. Here, and now going back to the original function, well we've already established that this thing cannot be 0. Cannot be 0. The denominator cannot be 0. But if you look carefully, there's another demand that you need to make. You need to make the demand that this thing here, because the domain for natural log has to be x being greater, strictly greater than 0. So your next demand is that this thing here has to be strictly greater than 0. So hang on. So just bear this in your mind, okay? We're going to come back to this later. So let's start again. The next demand that we need to make is that this thing needs to be strictly greater than 0, because that's a domain for the natural log. So we need to make the next demand is this, plus 10y. We need to make the demand that this thing has to be strictly greater than 0. So what does this mean? Well, rearrange it to make y the subject. So that would then be let me think. That would then be minus 10. That would then be this. Hang on, 10y, and then divide both sides by 10. So that would then be this minus x. So what that means is, in your mind, you've got to picture this: the xy plane, and then this. Well, imagine this thing here. That would then be the diagonal line. And then now let's discard this. Y has to be bigger than this thing here. So so it's everything along here. So the domain is everything along here. But remember, from our earlier demand, where the denominator cannot be 0, we had that line here. We had that line there, which was what was it? 1 over 10 minus x. Y cannot, it cannot lie on this line. The domain is everything. The domain is such that everything above here will be okay. Union with the fact that it cannot lie on this line. Okay, so the domain can be written as this. The domain can be written as this. Hang on. So the domain can be written as this. Everything over on this side is okay, but make sure it doesn't lie on top of this line. So the domain is xy belonging to the 2D plane, such that this thing here, it cannot be 1. Union with xy on the 2D plane, such that this thing has to be strictly greater than 0. So so this thing here is saying everything on here. This thing here is saying it cannot lie on this line. Okay, so that's your domain for this function here. For this function here. Okay. Next one So find the domain for this function here. So hang on, find the domain for this function here. So press pause and have a go. Okay, so to do this, when would this thing break down? Well, this thing breaks down when the denominator is precisely equal to 0. So you need to make this demand. Make sure that this thing, cannot be 0. What does this mean? Well, let's rearrange it to make y the subject. So add 3 to both sides. Exponentiate both sides with base e, so that will then give us this e to the power of 3, and then add 9 to both sides. That will then give us this. So so this is so when you see this, picture your domain. Picture it as xy on the xy plane. Y cannot be this thing here. Well, don't forget, this thing is just a constant, and this thing is just a constant. So it's like me saying this. It cannot be. Well, this is just a number. This is just a number. So I'm just saying, I don't know. It's about. Hang on, let me think. 20, 30. Well. Just imagine this is like a constant, 37. Let's just imagine that's 37. So what it's saying is that y cannot be this line along this line here. So this line here being e to the power of 3 plus 9. So it can be it cannot lie on top of this line. That's our first demand. So our first demand is that this thing cannot equal to 0. If you look carefully, you need to make this demand as well, where this has to be strictly greater than 0. So our next demand is this. Our next demand is that this thing here, hang on, has to be strictly greater than 0 because of the natural log. The domain for natural log is that it has to be strictly greater than 0. So what does this mean? Well, rearrange it to make y the subject. So it's like this. So so y has to be bigger than 9. So this is 9 here. This is 9 here. So your y-x plane. So this is saying y has to be bigger than 9. And earlier we had a line going through here where it cannot be e to the power of, what was it earlier? 3 plus 9, I think it was. Well, and then also you need to look at this thing here, and then notice that you need to make another demand. You need to make the demand where this thing here has to be strictly greater than no. You need to make this demand where this thing here can be equal to or greater than 0. Okay, so what does this mean? Well, it means this. Add 18 to both sides. So that means this. On your xy plane, x has to be bigger or equal to 18. So imagine 18 is here. So x has to be bigger or equal to 18. So it will be somewhere along here. And then earlier we said that it had to be bigger than 9. So we are talking about this region here. And then also there was a line where it cannot be on top of this line here, where it was e to the power 3. I think it was plus 9. I'm not sure. But the domain can be written as this. Remember, there are lots of ways of expressing the domain. This is just another way of expressing the domain. We need to we need x and y such that x is bigger than 18. So our domain here, x, y, x is bigger than 18, meaning this is 18 here. So we are talking about this region here where x is bigger than 18. We need to make the demand that y is strictly greater than 9. So let's just imagine this is 9 here. So we are talking about this region here. And then we need to make sure that y cannot be this constant. So there's a constant in here where y cannot be this line here. Okay, so this is our domain here. Okay.